Okay, now let's go to introduction. First of all, I will be explaining the definition of logical equivalent. The logical equivalent can be defined as the two statements which are P and Q are said to be logically equivalent if and only if they have logically equivalent forms. When identical component statements, variables are used to replace identical component statements. For example, when the statement P is true, if and only if the statement Q is true, the two statements are called logically equivalent. Besides that, the logical equivalence of the statement forms P and Q is expressed by the symbol P equal to Q in the equation.
Logical equivalence, we need to consider the conditional statement, or we call it as implication statement. For conditional or implication statement, we use symbol P implies Q. Next, for the inverse statement, we just need to add the negation symbol to the both side of the variable, and then we will get negation P implies negation Q. For converse statement, we just need to change the two position of the variables. For example, if we have P implies Q, for converse statement, we just need to change the position of P and Q, and we will get Q implies P. And the last one, for contrapositive statement, it depends on the converse statement, and then we just need to add the negation symbol to the both side of the variable, and then we will get negation Q implies negation P. Next, we need to know that the contrapositive statement and the conditional statement are identical, and the inverse statement and the converse statement are also identical too. Thus, for logical equivalence, we need to construct a truth table, includes every variable to be evaluated, and then we need to check the resulting truth values of the two statements to identify whether the statements given are logically equivalent or not. Steps to answer question related to logical equivalence. First, we need to construct a truth table, where in this step we need to identify the number of rows of the truth table. We will use formula 2 power of number of preposition. For example, if we have two preposition P and Q, we just need to substitute the number of preposition into the formula. We will get 2 power of 2 equal to 4, and we will have 4 rows of the truth table. Second step is we need to check of each preposition if the truth value is true or false. If the truth value is true, we write this symbol, and if the truth value is false, we will write F symbol. Next step is we need to compare the truth value of the two statements. If the truth value of the two statements are identical, then we call it as logically equivalent, and the truth value of the two statements are not identical, then we call it as not logically equivalent. We need to state whether the two statements given are logically equivalent or not, or we can use the symbol of logically equivalent.
Now, let us see some examples of logical equivalence. For example 1, we want to see either P implies Q equivalence with nego Q implies nego P or not. First, we create a truth table to check the result either it's identical or not. And then, we make a comparison between P implies Q and nego Q implies nego P. For each conclusion, make sure all the truth values are similar. After we check, there are same result for both statements, so we can say that P implies Q and nego Q implies nego P are identical, and we can conclude that two statements are logical equivalents. Then, for example 2, we want to see either P and nego Q and negation of P implies Q are identical or not. First thing first, we create a truth table to check the result, and we make comparison between P and nego Q and negation of P implies Q. For the conclusion, make sure all the truth values are similar. After that, we check either the result for both statements are similar or not. So the conclusion is P and nego Q and negation of P implies Q are identical, and we can conclude that two statements are logical equivalents. Last but not least, for example 3, we want to check either nego P implies nego Q equivalence or not with negation of P implies Q. As usual, we create a truth table to check the last result, then we make comparison between the two statements. For conclusion, we can see that example 3 is different with example 1 and example 2 because the truth value of these two statements are not similar. So we can say that nego P implies nego Q are not identically with negation of P implies Q. So the conclusion is these two statements are not logical equivalents.
So, from the example that has been shown, we can identify logically equivalent proposition using the truth table. The propositions are equal or logically equivalent if they are always have same truth table value. Either we got a compound proposition that is always true, no matter what the truth table of proposition that occur in it is called tautology, or otherwise which called contradiction. Besides, a proposition that is neither a tautology or a contradiction is called a contingency. Therefore, a conditional statement and its contrapositive are logically equivalent, and the inverse and the converse are also logically equivalent to each other. Other than that, from the example, we can illustrate different forms of conditional proposition. So that's all from us. Thank you.